Now we have all these rules for differentiation. We developed the derivative of a constant function. We proved the sum and difference rules. We developed the power rule. Now we're going to prove the product rule and the quotient rule. For the product rule, we start with the derivative with respect to x of f of x times g of x. Is going to use the definition of derivative. Is the limit as h approaches 0 of f times g of x plus h minus f times g of x divided by h. That equals the limit as h approaches 0 of f of x plus h times g of x plus h, I'm going to leave a big old gap, minus f of x g of x divided by h. In that gap, and I think you need to be a little bit bigger, I'm going to add and subtract the same thing. So I'm going to say minus f of x plus h g of x plus f of x plus h g of x. And what you can see here is that we added 0. Now in the first pair of terms, you can see that we have a common factor of f of x plus h. In the second pair of terms, you can see we have a common factor of g of x. So I'm going to do a few things in this next step here. We have the limit as h approaches 0. I'm going to factor out the f of x plus h in the first pair of terms, and I'm left with g of x plus h minus g of x. And I'm going to give that term its own denominator of h. And then we have a plus. I'm going to leave a little gap because I know what I'm going to do in just a minute. We're going to factor out the g of x. And we have left f of x plus h minus f of x divided by h. Now I could take the limit of the whole thing, but remember we have a property of limits that says that a limit of a sum is the sum of the limits. And so I'm going to write down the limit as h approaches 0 over there. Now, as h approaches 0, f of x plus h becomes f of x. And what's left? The limit as h approaches 0 of g of x plus h minus g of x over h. Well, that is g prime of x. As for the second term, as h approaches 0, g of x is g of x. And then we have f of x plus h minus f of x over h. As h goes to 0, that's f prime of x. And so you can see where this expression here for the product rule comes from. You will hear me saying u and v a whole lot, but this is the proof of the product rule. Now we're going to look at the quotient rule. It's going to go kind of the same. The derivative with respect to x of f of x divided by g of x is equal to the limit as h approaches 0 of f of x plus h over g of x plus h minus f of x over g of x divided by h. Now we have a complex fraction, and so I need to multiply numerator and denominator by g of x plus h times g of x. My result is that I have the limit as h approaches 0 of f of x plus h times g of x. Now I'm going to leave a big old gap because, like I said, this is kind of like the product rule went. The g of x plus h divides out in the first term. The g of x divides out in the second term. And I have minus f of x times g of x plus h. The whole thing is over h times g of x plus h times g of x. Now I'm going to add 0 in the middle here in the numerator. So I'm going to subtract f of x, g of x, and then add f of x, g of x. And we again added 0. If you compare what we did in the product rule, it's a little bit of a different form for this particular 0, but it's what works here. Now, as before, we have a common factor in the numerator of the first pair of terms, and it's g of x. In the second pair of terms, it's f of x. So we have the limit as h approaches 0 of. If I factor out g of x from the first pair of terms, I mean to say, then I'm left with f of x plus h minus f of x. All that's divided by h times g of x plus h times g of x. Don't divide anything out at this point. And then if in the second pair of terms I factor out an f of x, then I'm left with g of x minus g of x plus h over h and some other things. But I know for the derivative I want the x plus h term to be first. Therefore, I'm going to switch the order of g of x and negative g of x plus h by factoring out a negative. And then I'm left with g of x plus h minus g of x. And all that is over h times g of x plus h, g of x. And then I'll apply the limit to the two different terms using the difference property or the difference law for limits. As h goes to 0, g of x is unchanged. So I have g of x and f of x plus h minus f of x over h. That is f prime of x. And I'll put that in front. Minus, for the second term, f of x, g of x plus h minus g of x over h as h goes to 0 is g prime of x. And if you're keeping track, then the h's in the denominator went out with the derivatives. What we have left in the denominator as h goes to 0 is g of x times g of x for both denominators. That is g of x squared. That's our quotient rule. So again, you're going to hear me using u's and v's, but this is where it comes from.